So up till now, we've been doing factoring work with quadratic trinomials. So we've been factoring things that look like this: x squared minus 9x minus 36. A reminder that our quadratic in polynomial in standard form looks like this: ax squared plus bx plus c, which this trinomial that I just wrote is in that form, and it actually has a leading coefficient of 1. So we've been doing some work in previous factoring videos where we have then written this as x and x, and then we found two numbers that multiply to negative 36 and added up to a negative 9, which would be a negative 12 and a positive 3. That's how we've been factoring that trinomial. Now take a look at my first example here. I have x to the fourth minus 9x squared minus 36. So that looks a lot like my x squared minus 9x minus 36, doesn't it? Problem being that instead of having x squared, I have here x to the fourth, and instead of having an x, I have x squared in my given problem, don't I? So let me rewrite that so that you can notice that. So I already factored x squared minus 9x minus 36, but they're asking us to factor x to the fourth minus 9x squared minus 36. So what we're going to do is we're going to teach you a new method called factoring using substitution, and we're going to rewrite our given trinomial so that it looks a lot like this quadratic trinomial. But problem being that I have this x and this x squared here, and I'm letting one letter represent two things. So I'm going to define a new variable, u, and how I'm going to define u is I'm going to look here at that middle term, and I'm going to let u represent x squared. Okay, and then when I squared u, I get x to the fourth, and that's what I have here in the first term. So I'm going to replace x to the fourth with a u squared, and then I'm going to rewrite all the coefficients that were in the original problem, and notice how I now have a trinomial that matches that one, except that instead of writing it with a variable of x, I've wrote it with a new variable of u. Do you see that? So that's going to be this factor by substitution, in that we're going to take our original problem, which was not a quadratic, it was really a degree 4 polynomial, and we're going to rewrite it using a new variable u that's going to allow us to end up with a quadratic that we can then factor using the methods we already know. And we've already talked about the fact that this factors as u minus 12u plus 3. But now, don't stop there. So as we use our factor by using substitution method, the last step will be to substitute back what u represented. So do you remember that u is representing our x squared? So we're going to write x squared minus 12 x squared plus 3. Let's try that one more time. Let's try with a different example. Okay, we're going to factor x to the fourth minus 12x squared plus 35, which is not a quadratic polynomial because it's x to the fourth. Okay, but we're going to try to rewrite it as au squared plus bu plus c, right? A quadratic, but instead of using x, we want to use the letter u. So as we look at this, then u must be representing this x squared. Do you see that? So we're going to let u represent the x squared, and then we're going to square u. So when I square x squared, we get x to the fourth, don't we? Which is that first term. So this is, we're just verifying that our x to the fourth is really u squared there. See that? Now we're going to rewrite this original polynomial, but using u's instead of x's. So x to the fourth is u squared minus 12, and then u is representing the x squared, so I'm going to put a u there, and then plus my constant 35. And we know that the GCF there for factoring is 1, because we have a leading coefficient of 1, and so we know how to factor this. We need two numbers that multiply to a positive 35 and add up to a negative 12, which would be negative 5 and a negative 7. But now don't stop here. as your final answer because your original problem was not in this new variable u. Your original problem was in x, right? So now we go back to use the fact that we know that u is x squared, and we're going to substitute it back in there. See that? So then we're going to write x squared minus 5 times x squared minus 7. And of course, that's easy to check by foiling, right? If I go outers, I get x to the fourth. If I do my first, I get x to the fourth. If I do the outers, I get negative 7x squared. If I do my inside terms, I get a negative 7x squared. And if I do my last, I get my positive 35. And here's my middle term. So checking your answer won't be tough, okay? All right, now you may be thinking, well, I think I could have probably just gotten to that final answer without all that u business. And you're right, you probably could have. But the next video that you're going to see, we're going to have square root of x in there. So take a look at these. Take a look at these problems. This is not quadratic, right? It's got that square root, but we can factor this by using the same technique. Take a look at this one as well. This trinomial has rational exponents. So the exponents are fractions, but guess what? We can also factor those with using that u substitution method. So that's why I wanted to introduce that to you in this video with the x to the fourth. So go to the next video so you can see these more challenging problems.